Good night for everyone on the West Coast like me, and good morning for whoever is in Europe. Um, today, we're going to talk about scaling data from the lake to the mesh via OSS. I hope you're all ready. So let's start introducing myself. I am Luca. As you can hear from my accent, I'm from Italy, and I'm the chief architect at Telus Digital. And I live in Vancouver, BC. That's why for me it's 1:30 a.m. in the night. Just a brief intro of what Telus is. Telus is the second biggest telecommunication company in Canada, and Telus Digital is basically the website, the apps, and all the digital experiences on that serves the Telus business. So I'm famous for telling stories, and once again, I'm going to tell you a story. This story is a journey, right? It's a long journey. And like every journey and like every Italian story, it has to start with something related to food. And for whoever knows this famous dish or doesn't, this dish is called Oops, I Dropped the Lemon Tart. And is probably the most iconic dish of one of the most famous Italian chefs in the world, Massimo Bottura. And why is this dish important for this talk? Because this one represents a breakthrough in the tradition. It's a traditional dessert invented and revisited. And that's a little bit our journey, right? And our story started like many other stories with the infamous monolith, right? This famous historical piece of technology that slowly, across the years, evolved into some microservices, right? Sorry, Oracle. And from the microservices, we moved to smaller services, composable, right? Because how we saw the world of services to evolve was to divide and conquer capabilities and scale capabilities across different business units across the organization. And from these micro blocks, these Lego blocks, we moved to the modern times with functions, with serverless, with reducing at the bare minimum the footprint of our applications against the infrastructure. But like every application, the other side of the medal, the other side of the equation is about data. So what about data, right? Data went through a similar path of transformation and evolution, right? We went from the monolithical data lake, fully kind of characterized by the extract, transform, load processes, to bring it closer to consumption layers, to clearly more modern stream-based systems, right? But what was missing still in all this equation was how can we bring the speed of light? How can we create better and faster connections between data and our services? And this has been always the eternal question, right? How can we do that? And we all know the biggest challenge of this distance between our database, our lake, our aggregated data source, and our consuming application has always been data latency, right? Because the longer our application it takes to render, to show to the eyes of us, the consumer, the more sad we become, right? We don't want to have this phase. And in this kind of transformation, clearly, there was a very important element that is the distribution of data across CDNs, right? So we found that on the network, one of the easiest thing to bring data closer to the consumer was to bring it closer to where the connection edge was. So that's why CDNs, they solved a huge problem in static data delivery, right? So the asset delivery through CDNs. And more recently, with edge computing, we were able also to bring dynamics data to the edge. But this thing opens again, a million doors, a lot of questions, right? Because as the technology evolves, we have been basically going through phases of our networks to transform, right? And I don't know how many of you are familiar with the 5G transformation. I'm going to spend like a few seconds telling you a little bit of story about 5G, right? But 5G is not just the evolution of 4G. 5G is a transformation in terms of content delivery, data delivery, accessing the data as close as possible to the antenna, where your signal comes from, where internet comes from. And that's why 5G is a huge transformation. It's not only faster internet on your phone, but is mostly how can we bring the data as close as possible to the customer. But in order to do this, we need to consider some problems really of distribution and distributed computing, right? So clearly one of the things the 5G and this moving data closer to the edge are bringing is higher speed, right? So lower latency, faster time to render. Basically, you open your app or your website, bam, is already there. The other thing is the more we scale, the more we distribute. We add clearly a certain degree of complexity in how we manage data consistency. But if we accept the eventual consistency in nature of distributed data, we add more reliability, right? We can distribute, we can become more resilient. And so this is basically the kind of transition that we were kind of, let's say, assisting, looking at, that was running on this stage, right, the technology stage. And as a telco company, we couldn't be a passive actor, right? So one of the first things that we thought is that, well, we have a huge opportunity and we can be creative, right? And so a part of this story that I want to share with you all is what kind of creativity, what kind of mad science we put in place to try to accomplish this kind of very ambitious goal of bringing data as close as possible to the consumer, reducing friction between applications and data retrieval. So we started looking clearly at the status quo, right? And let's just walk through this picture together, right? So as a user, you connect to some sort of UI, and this UI connects to an API. This API is connected somehow to a model. This model is connected to a data source or a database. And what is very interesting is that this traditional model allows us to kind of look at the problem from different angles, right? And we can take a kind of a rule of thumb assumption that most of the operations that are going to run across our website are mostly read focused, right? That's why we want to optimize the cache. And if we think that there is a clear separation of concerns, if you look at the problem, that we can draw a demarcation line between the different operations that are running across our website, then we kind of took this as a great opportunity to apply some concepts that are more related to the world of banking, for example, right? I love banking, and I say, let's try to bring something of distributed computing, but still transactional, and to serve web scale. So that's why we kind of borrow this concept, the so-called CQRS, right? Very complicated acronym for Common Query Responsibility Segregation, just to say, let's separate read and write. Let's start from there, right? Let's draw that line. And so if we take the picture that we just saw and try to apply this concept to it, we see that we can clearly separate the command part, that is all the write, the operational part, to the query, right, the read part. And if you look at the traditional enterprise, when you are talking about write or command operation, you're looking mostly to interact with systems that are very old, right? They are transforming very slowly because they are living in the operational side of the business. While the read models or the query layer kind of serves more the customer experience, the user experience, right? So they have two different kind of time to market. They have two different roles and responsibilities across the whole enterprise system. So what we did, like every architect does, whiteboard and markers, because on a whiteboard, everything works. So we just took a nice whiteboard. Clearly, this one is not the photo of the whiteboard. I wish I could write so clearly, but we try to represent this picture, right? And look at holistically how we could reinvent this thing. And we kind of look at the different stages that I described earlier on of transformation and evolution, both in the service world and in the data world, to kind of reinvent something, try to find some mad science, right? And when I usually talk about this solution, I say, as an Italian, I'm trying to cook something that resembles the Italian tradition: simplicity, perfect taste, well balanced, and easy to make, but with a secret ingredient. So let's look at this picture, right? So we have a bunch of system of records that are represented by microservices. There is a broker in between, and this one triggers all the streaming pipeline, right? We have workers, but the cool part that we kind of assembled was this ephemeral entity storage, right? And the old GraphQL layer to represent some sort of consumption on top of this ephemeral state. And let's walk through this ephemeral state through the solution, right? And I told you, it's like cooking a perfect Italian dish, right? So, but here we are using organic. We are using open source. And like every perfect recipe, it starts from what we call in Italian the soffritto. Is the base, right? Oil, onion, chopped, carrots, and a little bit of celery, right? And in this case, it's Fastify. Why Fastify? I hope you are all familiar with Fastify, because if you aren't, well, this is a good homework, right? Fastify brings us the deterministic model inside of our application, right? So the plugin system allows separation of concerns, distribution across the development team, and it's elegant. It represents the Italian style, and that's why we saw so much value there, right? Because the simplicity and the transparency of the Fastify model that kind of came also closer to us and in an easy to access way through the Fastify CLI was the perfect thing that we kind of needed to build these workers, these APIs, and all the serving layer. But I told you that there is a broker in between, right? Data needs to flow from our system of records faster to where it can be consumed at the speed of light. And I highly recommend you all to look at this library, Kafka Node. I mean, it doesn't require any documentation. Is probably one of the best node libraries for consuming Kafka brokers. And downside, there is not a Fastify plugin yet, but easy to build. But let's go to the secret piece of this recipe, right? This entity graph, right? So what we tried to represent, we said, because everything is represented by cause and effect, right? Because everything is an actor model. The things that we were trying to reveal were this materialized view. How can we bring data as static as possible, as close as possible to the user? And in order to do that, we need those to represent, it has to be dynamic, so materialized view, they're a pain in the butt because they need to be manually refreshed, or you need to write a cron job. I mean, let's not go there. The nicest thing is that we were trying to represent all the relationship and try to kind of also support a very flexible user experiences and customer experiences at the speed of light, right? And so we said, we have the secret sauce. It's called Elasticsearch. Elasticsearch can represent this ephemeral graph. All the read, all the queries, is basically what Elasticsearch is made for, right? Run queries, search. And plus, thanks to the Elastic team and Thomas Della Vedova, we have fastify-elasticsearch in place, right? A super fast, super reliable library to connect to Elasticsearch. So if we take once again, a step back to that beautiful diagram, well, beautiful, colorful at least, we see that all those entities, they are flying into Elasticsearch, right? And now we have the opportunity to say, okay, once they're in this graph, how can we query them? How can we make them accessible to everyone? And how we can basically streamline all those entities that we are using TMF, which is a standard in telecommunication to represent business entities, basically a glorified open API standard. But we said, how can we make them flexible, accessible to everyone? And that's why we said, let's use GraphQL and connect GraphQL to Elasticsearch. So in order to do that, we use another organic tool in the open source ecosystem, graphql-compose-elasticsearch. I think it's a fantastic library that allows everyone to connect GraphQL schemas to Elasticsearch models. Phenomenal. You write a query in GraphQL and it's propagated as a resolver. Okay, should be back. Sorry for the interruption. Um, Sometimes being on a fiber doesn't mean that it's stable. But I was saying we are using TypeScript to map types and basically use a more kind of programmatic approach to do schema definition. And as you can see, I forgot to share my screen again. Live sharing. Okay, so that's exactly how we do type definitions. And if we kind of walk through how the model it is, clearly resolvers can be mapped through attributes and queried the same so that we can kind of unify the way we standardize the definition of the GraphQL interface. And we use CodeGen through our CI/CD pipeline to basically play the magic and compile everything behind the scene. And because I only have 30 seconds left, I will go super fast. But how we avoid to create a million GraphQL services and have to handle this schema stitching, we are actually using Apollo, and we are using Apollo Federation. So we have our service mesh, which is Kuma. If you never heard of Kuma, go on Kong HQ and you will find Kuma there. And we deploy services in Kubernetes. Kuma handles the service mesh, and we federate it through Apollo GraphQL. Well, if my connection didn't drop, I had more time, but you can check the talk that was recorded in NodeConf to see how this story will end. And you will know how to cook the perfect Italian tomato sauce. So I'm sorry that I had to cut pretty short. My time is over. I hope you enjoyed it and hack something with this tech and have a lot of fun. Ciao!